Hello. So, there was a great talk from Daniel before me explaining you what the service mesh is, and I'm also covering that a bit, but I'm not a native speaker, and I just ate something, so I'm much slower than Daniel was. So it might help to digest this again, what cloud-native microservices are. So why do I care about cloud-native microservices? So we join Swarm. We run cloud-native stacks, which means we operate Kubernetes 24/7 in data centers of our customers, which means on bare metal machines within their real data centers, but also within their cloud accounts on Azure and AWS. And since we believe in this kind of technology, we also using that technology to manage the technology itself. So we're using Kubernetes to create new Kuberneteses and to manage Kubernetes. So all our services are running on Kubernetes as well. So we have a control plane that gives you an API to create Kubernetes clusters. So we are also users of Kubernetes, and that's also why I care, like how do you design your services on top of such an infrastructure. Yeah, we're a great team, 25 people from 12 different countries, and we are fully remote, so the people are all over the place in Europe. And it sometimes happens that we do on-sites and we meet together, and that was the last one in winter, where we actually went Nordic skiing and did some biathlon shooting together. And yeah, there's one guy, this is our support engineer, like he's always really, focused, I would say. So what do I want to talk about? Shortly, give a brief introduction what cloud native is, but you heard this like several times, and I don't want to make it boring. And then how you run such services, how you do observability, monitoring, those kind of things, how you extend the whole platform, and then a little bit into like what the service mesh is and how that helps. First of all, cloud native. I don't when I first heard it, I was like, what the fuck? What is cloud native, and why should I care? There's already microservices, and a lot of stuff that is in that term was already for me in microservices, and so I didn't see the need to have that. Nowadays, I would say, because of the foundation and all the technology that is appearing in the cloud native foundation, I think it's valid to use cloud native as a term, and maybe even this combination of two buzzwords like cloud native microservices, which makes my ear bleed. But anyway. So these are the projects that are currently in the Cloud Native Foundation, and they kind of form a stack. They work together, not necessarily, they are open, they also work with other tools. But yeah, I want to go through some of them and explain how a typical stack can look like. And goals for microservices. My most important goal is I have a team, and the team can just run and do their stuff, and is not blocked by anybody else, neither by operations or by another team or whatsoever. I just want to have teams that have ownership on a specific business story, and they can just do what they want. They can release when they want, and they are not blocked. That's the most important thing for me. Besides making it faster and being able to experiment, and obviously if you have all these small services and a highly dynamic infrastructure, you also want to have that resilient, and you want to have building blocks to make certain parts of it scale, because and so what does cloud native mean? The most important part, combining that with microservices for me, is that it's the definitions are declarative. So you, like in Kubernetes, you have manifests. You have a YAML file that declares what you want to have, a desired state. And so it's not that much that you have like a run book or something like that. I mean, I think using Ansible with YAML, and then it's still a script in a way, right? I mean, it just executes one by one, and that's not declarative for me. Even though people say you can do declarative stuff in Ansible, I think it's not true. I mean, I never saw somebody doing this for real. But yeah, this is very important. And then also that it's composable, that you have small building blocks, and they are building up without having like a framework layer that is like standing in your way, and like this typical thing we already saying for years, that like the first pass was like standing in your way. You needed to work around a bit if you wanted to do something else than the 80% use case that it was covering. So you're building up, like Werner Vogels from AWS said this, like about 10 years review of AWS. It's about building the small pieces and then get higher up the stack. So you create abstractions, but you create these kind of composable building blocks. And yeah, obviously it's like it's totally dynamic. And for me, that's a fundamental belief, and I think a lot of people in the community as well, is that infrastructure shouldn't be a black box. So I totally agree that open source is a vendor lock-in, as AWS is a vendor lock-in. But I believe it's better to have open source infrastructure than having a black box from some vendor that I don't know what it's doing underneath. I mean, if you're like building some business functionality, you don't necessarily have to care about this. But I do infrastructure, and I care, and I think this is important, and I think that's also important for all the players that are, like for instance for Google, Red Hat, IBM, that they also share this kind of, like, Google is sharing this because they did this in their data centers for very long, and people were asking them, like, why do you want to have this patch in the kernel? I don't get it. Why are you doing this? And now more people are using the same kind of technology, and that's helping them internally to like make it easier to onboard people, to understand how they are running infrastructure, etc., etc. And so for me, that's a core belief that it should be open. And yeah, that was my cloud native explanation. So how do you run services? Typically, and you heard this in some talks before, you have some sort of functions in every service, and it starts with like configuration, secret management, you need to register the service, you use service discovery, all this kind of things. Then you do metrics and logs and tracing, and then you have circuit breakers, and you want to have identity in your service that enables you to do authorization and authentication, all those kind of things. And these are like cross-cutting things that you have in all of your services. And the problem is you shouldn't do that with shared code between all the services. And using libraries for that is a problem where you make it hard to introduce new features, like new cross-cutting features, like you have a new feature in your monitoring, or you have, for instance, you have a different kind of topology in your monitoring, and you would like to compose your monitoring in a different way, and then you have a library that needs to send to different endpoints. Instead, you reverse that in the cloud native sense, that you expose the metrics and somebody else comes and picks it up. So it's a push versus pull concept. And yeah, obviously it's also problematic if you want to have other languages. So if you do something with Spring Cloud and then suddenly you want to do something with in another language, you most likely have a problem having the same kind of functionality, or needing to reinvent the same kind of functionality in the other language. And obviously, third party is a problem, because how do you integrate third-party systems, software, services into your infrastructure if everything else depends on the libraries that are used in the services that you create yourself? So starting with running services within Kubernetes, I just make it short because I think most of that is clear. I just want to show you some of the concepts. So as I said, you have declarations, you have manifests, and those manifests define resources within Kubernetes. And there are lots of them, but typical ones would be a deployment, a config map, a secret, and a service. And this looks like this. It's like simpler than the actual YAML, just to make it fit on a slide. So I want to have like 2 containers. The strategy is rolling update. I give it a label called myservice, application myservice, and I want to run the container myservice latest. That's the deployment. And the deployment, if you apply that to a Kubernetes cluster, Kubernetes would take care to start 2 instances of that container image. And within that configuration, you also pick up a config map and mount it into the container as a YAML file. And the same thing you can do with secrets. And then you can also define an endpoint where your service reports if it's still alive or not. So if that URL is requested and it gets an error back, Kubernetes would actually kill the container and start a new one. And then you also have another endpoint that tells Kubernetes if the service is ready or not. So if the service should receive requests or not. So either you go into maintenance, or a typical scenario is the rolling update. So you would receive the notification that the container is taken down in a few seconds, and then you can give the ready signal that you stop accepting connections, you drain your existing connections, and then you shut down. And that's the way how you can do graceful updates within Kubernetes without losing any kind of connection, because you're not interrupting that. There are signals that let you do these graceful rollouts. And then you can aggregate the containers into a concept called a service, which makes Kubernetes load balancing over those containers. So you define a service YAML, and you say, okay, this is a service and it's available on port 8000, and with core DNS or former kubedns, you are able to have DNS on that service. So within the same namespace, you can reference the service by myservice, because in the container, the search domain, my namespace, service cluster local is injected. So you can talk to your service within the same namespace just by calling the host name myservice, which makes it easier if you want to have multiple environments. You can always talk to myservice, and it's in this namespace or in that namespace, so test namespace or production namespace, things like that. So these are those 4 parts of every typical microservice. You have configuration, you have separate configuration, you have separate secret management, you are able to register and discover other services. So that's what Kubernetes gives. Who of you is running Kubernetes in production? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, nice. Oh yeah, I run many hundreds of Kubernetes clusters. Yeah, there are other resources within Kubernetes, yeah, just to briefly go through them, Ingress is a way to define external traffic coming to your services. So it's like a layer 7 hostname routing that you can do. So you get like for instance an Nginx as an Ingress controller, and you have an ELB in front in AWS, so the traffic comes into the Nginx controller, and the Nginx controller picks up the Ingress resource from the Kubernetes API, and then redirects you to the actual, like, where is the service running. So it's the way into the cluster from externally. And yeah, you have different kind of workloads that you can define. A daemon set is a container that is running on all machines. Then you have a stateful set that is a little bit easier to handle if you have a volume attached to the workload. You have cron jobs, and then you have a bunch of policies, and that's also very interesting. So if you're familiar with like how AWS works and how IAM works, and how you can give your EC2 instance a role that it allows to do something, you have the same kind of system within Kubernetes, and so you can define a role, and you can define a role binding, which allows you like via a service account to talk to the Kubernetes API. So if you have a service that runs in Kubernetes that wants to talk to Kubernetes itself because it needs some information, needs to read out some of the resources, then you can define that in the role and the role binding, and it's like IAM. And but you also have things like pod security policy, which defines what the container is allowed to do on a machine. Or network policies that like dynamically create filtering of traffic for your services. So you define which service is allowed to talk to which other service on which port. It's like basically like IP tables work. So now you have all these resources, and you need manifests for all those resources, so you need to have a way to bundle them up, and that's Helm Charts. So you can create all your YAML manifests, and then make an application out of that, because like typically a service has not only one manifest but many, and then a Helm chart comes in, and the nice thing is Helm adds the templating. So if you want to run the Helm chart in your test environment or in your production environment, you can use Helm to change the configuration of within the manifest. You have some templating, and within the cluster you have a small daemon called Tiller that actually deploys or applies those manifests to the cluster. And this is an example of our current pipeline. And so yeah, the interesting part here is this pipeline, when things are merged, they actually deployed in all installations of all customers that we are running. So the thing is, some of those environments are behind a firewall. And as you can see, we're using CircleCI as a build system, which is obviously not running within the data centers of our customers. So we need to have a way not to push into an environment, but actually to have a daemon there, and that pulls the information. And what we do is, like, if somebody merges a PR, then the build is triggered within CircleCI, and after tests are run, build is ready, the container is pushed into Quay, and also also Quay has an application registry where you can store charts. So Helm Charts can also be stored within Quay, and that way we push also the Helm chart into the Quay registry, and then Circle CI at the end creates a GitHub deployment event. And then we have a daemon called Grotsman within the cluster that watches the GitHub deployment events and then actually pulls the, or tells Tiller to pull the chart from the Quay registry and then actually applies that to the cluster. Questions about that, running and building, deploying things like microservices in Kubernetes? Who of you thinks it has a very cool, yeah, the microphone? Where's the microphone?
Where do you store your
the question was where we store
where do you store secrets? Yeah, in Kubernetes itself?
Yeah, we store secrets within Kubernetes itself.
Do you find it secure?
So they were very unsecure in the beginning because they were just like plain in etcd. Now they're encrypted. Also, our etcd volumes are encrypted, but there are still things to be worked on. But I truly believe that the way how it's worked on is better for the future than to do something myself in that sense. But you're also using Vault for creating root CAs for every cluster. So every new Kubernetes cluster gets a root CA, and we're signing new certificates and rotating them, and we do all this through Vault. For the services, the rest of the secrets are held within Kubernetes itself, yeah, as secrets.
Secure.
Yeah. Who of you thinks has a really nice deployment pipeline on Kubernetes? Because come to me after the talk and tell me about it. I would like to learn more about this. Observing your services. What do you say? Yeah, again, just repeat this. Try to minimize the use of shared libraries. And you may have heard this before. There are a couple of container patterns that help you doing this. And so there's this sidecar, which is like a companion container. It's just you have additional functionality that you want to have separated. You have a kind of a separate way to release these kind of features, and they're loosely coupled, and still they run within the same namespace and share a lot of stuff within a pod with your actual container, with your application container. And very similar to that is an ambassador, which is a reverse proxy that is usually next to your application, and it just enriches your functionalities. If you saw the talk by Daniel before, the Envoy proxy is used in Istio to enrich a lot of your communication between services, these kind of things. So the most interesting part here is if the proxy understands your protocol. Like, I don't know, you just can have a varnish next to your web application if you want to have some caching and just want to rely on how varnish handles caching instead of building this in your application, right? That's an example. And the adapter, that's pretty interesting for monitoring things. So if you have legacy or third party, then you probably want to have an adapter that kind of transforms the output of the legacy application into something that fits into your whole other microservice ecosystem. So it's usually like a sidecar next to a service, and then you can add some like log shipping or transforming metrics that are pushed out and then transforming that into like a Prometheus metrics endpoint, things like that. Yeah, so as I said, rolling out or changing, if you change a library and then you have to update all the services with a new version of the library, it's kind of similar with the sidecar containers, because you also need to roll them out in all your services if you run them. Like, think of Istio, where every service, like you have hundreds of services, every service has a proxy right next to it, and then you have a security fix for the proxy. So you need to roll it out in all services. So you don't get rid of that, and it's still there, but it's loosely coupled, and it's just a matter of automation and robustness of automating this and rolling this out, because it's not highly coupled with your service. It's loosely coupled, so there is a way to roll it out, and a library, there's no way to roll it out, right? I mean, besides rebuilding the whole project, and then the project fails because there are some structures, like some types that do not match anymore, things like that. You cannot like automatically recompile all your services without the team looking at it, right? Prometheus, monitoring. So I already mentioned that the way how Prometheus handles monitoring is a little bit different than most people are used to, because Prometheus scrapes endpoints to collect metrics, and it's not that you push out metrics to the system. And the nice thing is that this really makes the monitoring composable, and you can run even multiple Prometheus collecting different kind of endpoints. And if you want to have the Kubernetes infrastructure monitored, or if you want to have an application within a namespace monitored, you can even create different Prometheus that have overlapping services and fetch those kind of metrics. And so it's much more scalable in that sense, because if you want to have one Prometheus and then have thousands of microservices, it's not going to scale up. But since you can run multiple of them, and you can define your domains where you want to fetch those metrics, you can also say how the retention for that is, and the aggregation and the long-term storage for different kind of metrics that you're collecting. You can compose it in every kind of way you want. And that's the most interesting part. And yeah, it integrates with Kubernetes, with the Kubernetes service discovery. So you launch a new service, it has the endpoint / metrics, and it's automatically scraped by Kubernetes. And obviously, there's also a Helm chart. So you just apply the Helm chart to Kubernetes, and you have a Prometheus running within Kubernetes, monitoring Kubernetes, and every workload that is in Kubernetes. And yeah, there are things like node exporter that collect information from the host itself, and there's kube state metrics, which collects a lot of information about events happening in Kubernetes. Yeah. Obviously, here you use a library to create this endpoint, or you create an adapter. But still, this, as I said, the composability of Prometheus enables you to not having to roll out a new library to all the services if you want to change the topology of your Prometheus. Fluentd, another project. Yeah, I mean, it's logs. That's it, right? It ships logs, and you can do all sorts of structured logging and filtering and things like that. And it's just there's nothing really you usually also ship logs away, and you don't have maybe in the past you had who has a logging library that is really bound to some technology. I don't know, I've used Logstash before and Elasticsearch, and now we're using FluentD, and I think there's not that much interesting in there. Tracing, that one is more interesting. So as we all know, it's very complex in a microservice world to discover what's going on between your services. And so how do we do the same kind of principle with tracing? So there's the open tracing standard that helps us to have a predefined protocol format to exchange this information. And Jaeger is a pretty young project that uses that comes from Uber. And it's a web UI to actually present you this kind of information, and also a backend with like some adapters to different ways to store that information. And the nice thing is for me is that the instrumentation libraries exist for multiple languages, and they don't leak too much into the application. So the application doesn't need to know much about that it's getting traced. And again, if you think of Istio as a service mesh, Istio adds a lot of those tracing capabilities even within the ambassador, the envoy proxy next to your service. So for a lot of, at least the request tracing things, you just don't need to do anything with your application. Cool, so we have those three covered as well. Next, I would like to explain a bit what you can do with Kubernetes itself to extend it with, like, given the kind of design patterns, like the composability, and also this, exposing information and then building it up from bottom to top. Like, how can you do that with some cross-cutting functionalities that are like specific to you, that are maybe more business driven than like these operational things that I just showed you. So the concept within Kubernetes is a controller that manages the resource. So you define the resource, which is the desired state, and then something needs to take care that this actually happens. And this happens in a loop all the time. So you have the desired state and the actual state. This is what is defined. That's stored in etcd, which is a storage that is consistent. So it's not highly available, and it's a bit of a challenge for people to run it, especially on dynamic environments, because if you have a network partition, it will be offline and not available. But this is because of the cap theorem, so it's consistent. But this is necessary to define your desired state, because you need to rely on that this is what I said, how the infrastructure should look like, right? So the controller loops over the information that is in Kubernetes and what actually is there. So the pod controller would, or the replica set controller that checks if a pod is there and how many of them, which is like constantly look, like 2 are defined, 3 are running, oh, I need to kill one. 2 are defined, 1 is running, oh, I need to start one. And it does that all the time. And there are controllers for all the resources within Kubernetes. And it's a pattern that we, because we are doing infrastructure, also use a lot, because it's a retry logic by design, right? It always like tries to transform everything into the right state that you defined. So some people call this an operator, although it should just be a custom controller. I think that's how it's called in Kubernetes itself. So you can define your own resource. And so you can create a resource definition and then write your own controller. And there are controllers that are doing things like creating Prometheus within your cluster or creating Elasticsearch instances within your cluster. So the effect is, if you do kubectl create or apply and then the file name of a YAML file, that's the way how you apply something to the cluster. And you can now write a YAML file that defines an Elasticsearch instance. So you do kubectl create elasticsearch.yaml, and then you have a new Elasticsearch. That's what the controller does for you. So it looks at the custom resource definition Elasticsearch, and if it finds there's a new one, it would just transform this into an Elasticsearch deployment, which is another Kubernetes resource. So there's some sort of delegation, like the Elasticsearch operator sees its resource and then creates another resource, and then the controller there takes care of that. So you can delegate different things. You can also create multiple resources. That's the way how you compose. That's the way how you abstract things. And you still have access to all kind of levels within Kubernetes. So that's just an example how you can do your own operator. You have a certificate resource, and the Cert operator talks to Vault and issues a new certificate if it finds a resource within Kubernetes. And then this operator stores the certificate as a secret within Kubernetes. And if the secret is deleted, the controller would actually take care of creating a new one. And if the custom resource for the certificate is deleted, the controller will take care of deleting the certificate from Kubernetes. So yeah, we ended up, because we like microservices and we see benefit in doing that, we also came up with micro-operators. We have lots of operators doing different small things within our infrastructure, automating all the things that we before did by ourselves, right? I mean, it's like you need to issue certificates and put this in your service. No, we have an operator that does it for us and even rotates them like every day, things like that. And that's why we built a small library that helps us doing this. Yes, I said we shouldn't use libraries. But yeah, there's some boilerplate that you have in every operator, talking to the Kubernetes API, doing this reconciliation loop, those kind of things. And yeah, it was just like obvious that we wanted to have this in a library that helps you to write a new operator within a couple of minutes and not like, copying some code that have to refactor in the newest one and then go back to the olders and do the same thing and yeah, whatever. That's how you extend Kubernetes. Do you have questions about extending Kubernetes? Somebody? No.
Which databases do you run on Kubernetes and which controllers do you use for that? Or operators, actually?
I mean, we are running Elasticsearch and Prometheus because we are more on the operational side. So I think there's no other database, etcd obviously. But our customers are running, they're running Elasticsearch and Kafka. I think there's no Cassandra yet. I think that's still early stage, also regarding support from operators to have this as a service, more or less. So I cannot say, probably Postgres or something is out there. I mean, they have volumes on AWS and they can just reattach them on new nodes. That's fine for them. yeah, but nothing really big that I would compare to like a Mesos installation where we run a big Hadoop cluster for a customer at the moment. No. Yeah, mesh your services. What this is time share? That's good. As you heard before, there's a new project called Istio, and that promises to do a lot more with your services, and it's a way. In a way, I think it's Kubernetes 2.0, because it's just the logical step of like going one level higher in the stack and making it much easier to run microservices on top of Kubernetes. And it takes away a lot of the pain that people have at the moment. Obviously, there's, again, more complexity that you add to your stack with Istio. So if you just learned how Kubernetes works, you now need to learn how all this stuff works in Istio. But I think it's really promising, and the way it works is the right design. Like compared to Linkerd, I always had the feeling that's something that has overlapping functionality and also kind of leaks, and like from an abstraction point of view, and it's not a really natural fit to Kubernetes. With Istio, I have the feeling that's a natural fit. That's something that like enhances the way how you run services on Kubernetes the right way. So. Yeah, I don't know if you saw the talk by Daniel, but this is the architecture overview, and I think the most interesting thing is, like, besides you already learned that Envoy as an ambassador is a proxy, and that it can enrich your communication in the sense that you talk HTTP to Prometheus to Envoy, and then Envoy talks gRPC between the other Envoy of the other service. So it enriches that kind of communication. It also enriches communication in terms of having mutual TLS. That's the Istio auth component, or sometimes referred to as Istio security. Yeah, that's basically doing what we before did with our Cert operator, where we used Vault to issue certificates and store them. And this is just a control plane that gives you this kind of functionality out of the box, and even in a transient way into your services, without your services needing to know anything about that. And the interesting part is that the envoys are collecting information, so-called attributes, and sending them to the mixer. And that's something you may be also familiar with, like with middleware, where like your API gateway has some middlewares that do auth or something like that. So you have like pluggable middlewares that you want to have in your API gateway, and that's what the mixer does. And the nice thing is the definitions you create for the mixer for the is again a manifest. So you declare something. So there's an example how to create an access log from all your services, like the typical like web server access log. And you can do this with the mixer. You just create a handler that puts the attributes in lines, and then you get an access log from all your services, and you can also do enforcement in the sense of I just want to have this service talk to Quay.io/giant-swarm/something and to nothing else. So you define an egress policy on layer 7 to define that the service is only allowed to talk to that website. And you can, again, define this in a manifest, in a declaration. And then you have the pilot that allows you to do all this kind of like canary deployments and smart routing if your service is not available, doing backoff, all those kind of things. Yeah, as I said, the building block is Envoy, and that's coming from Lyft. This is also used in other projects, and yeah, the Istio version is just enhanced with a couple of things. Yeah, that's the middleware. Already said this, and that's the pilot. And that's auth, and oh yeah, that's very important. So don't use it in production because it has exactly the problem I explained before. So you cannot upgrade at the moment, and they promised to upgrade when there's Istio. There will be upgrades when there's Istio 1.0. But at the moment, you will run your services with sidecars next to it, and there's no way to upgrade them. So don't run it in production. It needs some time. Actually, I thought I have the slide with microservices again. It's too far. So there was another one that had like authentication and all these things. So now I kind of like all this cross-cutting functionality is covered by those kind of cloud-native infrastructure components, and yeah, that enables you to run any kind of workload within such a complex system without worrying too much about all this like boilerplate, all this kind of cross-cutting things that you need to do to make a service observable, to make a service behave nice, all these kind of things. That's the whole idea behind a cloud-native microservice platform, to not have the problem. I mean, don't know if you saw Stefan's talk yesterday, don't have the problem of creating these kind of microservice platforms that stand in your way, that just like make it hard to run your microservices. Yeah, so going back to the goals, yeah, the idea is focus on the business logic and not build and not having problems with those cross-cutting functionality that are mostly operational, that you don't have to care about. And yeah, should you do this yourself? I think no. It's not just because we're offering that as a service. I don't care if you go to Amazon or go to someone else to get a Kubernetes, but I truly think you shouldn't do it yourself. Because the complexity is just growing and growing. So there's now Istio, and all the components that are involved make it really complex. To make the complexity less to run applications, and that's what you want. You want to run applications without much complexity. And adding the complexity to your own stack by yourself doesn't make any sense. And I think that's the same that Uwe Friedrichsen told us this morning. It's a managed service that you want, or a cloud provider. But still, a cloud provider is also a lot of automation work that you need to do, and also a lot of learning. So it's still good to talk to us. So, thank you. More questions?
I have a question. You did not mention persistence as an important part of the microservices. And and you mentioned then that you are using EBS volumes on AWS, for example. And I was wondering how you do that on the on-premise installations. Do you have a big block storage device available everywhere, or do you have a custom solution for that? Because I think persistence is still a thing.
Yeah, so the on-premise is always a problem, like how you do persistence. So the problem is mostly that you don't really have a dynamic provisioner. So you can do iSCSI volumes, but you manually create them and make them available, and then you can attach them to services, which is fine, but it's not as easy as like I write a manifest and then it's magically created. So you need to kind of like create the loon on the iSCSI and like get the credentials and write it down in a manifest, and it's this one that you pre-created in a way. That's one way. Yeah, you can use NFS, and I think there's even a dynamic provisioner for NFS, but this is not really what you want. And there are a couple of vendor solutions. So like you can get something from NetApp that plays with Kubernetes, for instance. And they're software solutions. So some of the vendors have software solutions, and there are things like Rook.io, but everything is pretty early stage, I would say. I mean, we have run a distributed file system within our own data center for a couple of years, 2.5 years or something, and that was fine. That's probably the best solution you can do, having software-defined storage, and not having some hardware boxes that are very expensive. Yeah.
My question about logging. Do you use any solution for buffering logs between FluentD and Elasticsearch?
At the moment, I don't think we have anything like that in the stack.
I just a question because we also don't use any, but I had some recommendations that it is better to use something in between in order to not to lose some, in some cases, logs.
Yeah. No, we don't do anything like that at the moment. Yeah.
Okay, thanks.
Further questions?
Yeah, over there.
Where?
Yep.
Yeah, sorry for sitting on the side.
No.
First of all, thanks a lot for this overview over the more esoteric parts, which I really enjoyed. I think that at the moment many people still don't manage to really use the full power of the cloud native ecosystem. So I would be interested to know how many of your customers or you yourself really take the time to find out what each of those building blocks really can do for you and really start to integrate that into your own platform. Or is it more like punctually here and there?
No, they're actually really looking into that that ecosystem and using those tools. And some of them want us to actually provide some of the tools as a service. So, like for instance, Prometheus, they have like 25 Kubernetes clusters, and they don't want to run Prometheus in every single of those clusters, and they just want to get a Prometheus by us from the control plane. And the same for tracing and those kind of things. So they want to have these kind of tools as a service and then use them. But currently they're also running them themselves. In a way, just like we provide them the Helm chart, and they just like start their logging stack and their Prometheus and stuff like that on a fresh cluster, or even automate this through our API.
The other thing I was wondering is, how do you share the responsibility between you, who operates the cluster of the customer in the customer's data center or AWS account, and the customer himself? Like, who goes to jail if something really, really bad happens?
The contract is very long. I mean, that's a nice question because we're working with enterprises, and we have access to their data center and manage something that is running in their data centers, and they run all their software on top of it. So. yeah, as I said, legal is a way to define like whose responsibilities are there. But practically, we have a Slack channel together with the customer, and he always has access to us as the people who are running the infrastructure. And it's more we are the SRE team within the company that you can always talk to, and not we are a public cloud where you can create a ticket somewhere and that's it. We're just we're responsive, and we wear all the pagers, and even if that's caused by an application of the customer, we would be woken up and then tell the customer, hey, there's something going on in that namespace that is leaking, and it's killing the cluster.
So do you give out cluster level root access to your client?
Yes.
So you have shared root.
That's, yeah.
Okay, cool.
Yeah. That's the whole
DevOps.
purpose. That's the whole purpose. They have full access to vanilla Kubernetes clusters, and it's not a giant swarm cluster that is in any way crippleware or something like that. Yeah.
I would say thank you, Timo, and give it up.
Thank you.